This will be a two-part video series, and this is part one. Howdy, it's Mr. Pete again, also known as tubalcain, and today I'm going to do a shaper project on the road shaper. I've done several other videos with the road shaper, just describing the machine and all of that, but let's do an actual project today. And what I'm going to do is to make a hammerhead. Now this is very similar to what we did in my shop classes over the years, but the last time I made one would have been 1988. So I forgot some of the dimensions, so alright, let me show you what I'm going to do and where I'm getting the drawing. Well, these are the only examples that I have to show you, but here we have a Stanley. Oh, sometimes it's called a cross-peen hammer, sometimes a machinist hammer, sometimes a riveting hammer. Here's a similar one, a plum. Never been used. And here's an S-swing, but this is a sheet metal setting hammer. And I've talked about that before, for setting a wired edge or something of that nature. Alright, this is a General Metals book by John L. Fire, and he wrote many industrial arts books, metals and woods. But in here there is a blueprint for, and he calls it a riveting hammer. Well, I've given John the credit for this, and I don't think this is breaking a copyright law. But notice that this is made from 5/8 stock. Now I want to make it out of 3/4 is what we use at the high school. So in order to do this, now this is totally against the rules and the law, but I put it in the Xerox machine, which is actually a copying machine, and by trial and error I figured out that it has to be 123% of this size in order to equal a 5-inch. So that's done. And this is the picture after I butchered it and changed or added a few dimensions, correcting them to what would apply to the 3/4 inch. And I'm not going to show all of this layout. Maybe I'll go through it real fast and put it at the end, because the purpose of this video is not to show you how to do a layout, but how to use the shaper. But notice on the finished sample that I made, we got some beveled corners or chamfered corners. We've got a slot. Now that I will do on the milling machine. Matter of fact, all of this could be done on the vertical mill in 10% of the time, and then tapering this off. So that's a shaper project, and this is a shaper project. I should get that out of the way. And the contrast is different, but that's what it looks like. So I've already been through this once in my, shall I call it, rehearsal. Let me also say that in my machine shop class we made this out of tool steel, and then we hardened it and we surface ground it, etc., etc., and took it to a totally different level than what I'm going to do here. This is cold finished steel. This is actually a useless project, but many shop projects are meant to learn certain operations. We don't really care about the end product. I'll throw this away. Alrighty, the layout is done, and that's shown, as I told you, at the end of the video if you want to see it. And it's ready to go, and the first thing I will do is to mill, or should I say shape, these bevels up to that line. So that's 4 setups and 4 cuts. And I will cut that all in one pass. Not too concerned about the surface finish. Okay, I'm in the shop with the road shaper, and let's talk about the setup. Now some of this I have done ahead of time because you have seen me do it or talk about it in previous videos. For instance, I have already set the stroke length so that it's really only about a 1/2 inch stroke, maybe a little more. And the speed, I'm not sure how many strokes per minute, but it is the maximum. And I have set the strokes so that it will be located right across the bevels. So let's talk about how to set this up in the vise. Well, this is how I want to set it up. This, of course, is the finished one. That's the new one that I'm actually going to machine. I just have it in here so you can see what I'm doing. Notice that it's on a parallel. Now, I looked and looked through all of my drawers, and I thought that I could hold this with a V-block of some type so that it is held at a 45-degree angle in this position. But I could not find one, so here's what I came up with in the way of a setup. Let me take this out. There are probably all kinds of ways of doing this, but this is a Starrett square blade, and it says hexagon on one side and octagon on the other side. But anyway, the octagon side is 45 degrees, so that's how I'm going to make sure that I have it in there at a true 45, not like this or not like that. So the whole idea here, if I can get that parallel under there, and the vise is just barely snugged, and I'm using a couple of parallels here, which really are just pieces of key stock that bring it up to the right height. And I will check here to see that is 45 degrees, and possibly loosen the vise just a little bit to bring it into compliance, and then tighten it down. And I will have to do that 4 times because I'm going to make 4 bevels, 1 on each corner, up to that line. Clear as mud at all? Now, I suppose you can use a little square head or something similar to make the setup. Use your originality and creativity. Next, let's take a look at the tool. Now, I set that tool, which I've been using, it's a round nose, nothing special. But at the angle that I've got that set at, and I don't know what it is going to give me pretty much the final angle here, and it doesn't matter what it is. I think that's a pretty good looking angle. Now, I want to set the depth, because this flat should be about 1/8 inch wide, but it doesn't really matter because it's just for appearance. But we want all 4 to look exactly alike. So I'm going to touch off, and I have already determined that it will be about 70 thousandths deep to give me that width. Make any sense? I am often using the hand wheel here to move the machine back and forth, the tool back and forth. You won't see my hand doing that, but certainly do not turn the machine on until you are sure that it will not crash or damage the machine or the work or anything like that, and make sure the work is tight and cannot move. I've already done that. I'm feeding the tool down as I move the tool back and forth until I just touch. Putting a piece of paper in there wouldn't be that useful. Okay, I am touching. Now I'll move the tool out of the way. I'm cranking the cross rail crank so that if I turn it on now, nothing will happen. I have zeroed out the collar up here, the graduated collar, and I'm going to feed down 70 thousandths. Actually, I'm on 10, so I'm going to crank in to 80. All right, that means I have moved it down 70 thousandths. Once the tool is engaged and starting to cut, I'll be cranking in here, then I will put it on automatic feed with the flat spot down like that, and that will be a feed of about 4 or 5 thousandths per stroke. This machine is kind of noisy. I'm not sure you're going to be able to hear me as I feed, and the cutting tool comes down to the layout line here, that's when I will disengage the feed, turn the machine off, back it up, and rotate the work, and I'll be doing that 4 times. Let's turn it on and see what it looks like. And you can see that I came right up to the line, and that gives me a nice termination there, that angle. All right, now I will take it out, rotate it 90 degrees, and do it again. And that didn't take very long. The finish is just okay. It's not great, but it's good enough. I know I didn't use oil, but let me mention something about safety. Make sure you got your glasses on, and do not stick your finger or any other tool in there to remove chips. Be sure and use a brush. You can't miss with the brush. And you can sacrifice the brush if it gets caught. But don't get your fingers in there. And again, let me repeat, turn the machine over by hand with a hand wheel to make sure that it will not crash. And the setup will be done the same each time using this 45-degree blade. I'm certainly not going to show that every time. Okay, this is the second corner. Okay, that was side 4. Looks pretty good and uniform. And now on to the tapered end. I've already changed the length of the stroke to about 1.25 inches or so off camera. And now the position of the stroke is not quite right, so I want to move it back a little bit this way. Just a little bit. That's perfect. Now I'm going to change tools. So I'll take this one out. And that's what it looked like. And I'm going to put this one in. But I have to raise, or I should say lower the whole table a little bit. Well, now that I've changed the tool holder, I will have to change the position of the stroke again. That's right. You want the tool to come a little bit past the work on the backward stroke as well as on the forward stroke. That gives the clapper box time to drop down and get in position.